Half a day students, for your continuation of today's lesson, we're actually applying what we learned in the past few lessons and using them all together at once. So we're going to recall our zero product property. So our zero product property tells us that if A times B, let me just get a different color here. If A times B equals 0, then either A equals 0 or B equals 0. And we've seen this before where we have two factors, a factor of two binomials, right? And we equate each of them to 0 and solve for n. So that's basically what we're going to be doing for this whole section. We're going to be solving, we're going to be factoring, and then solving for our variable. So applying the zero product property here, we're going to equate n plus 2 to 0, or 2n plus 5 is equal to 0. So in order for this to equal to 0, one of these has to be 0. So we're solving for n. We're going to subtract 2. N is equal to negative 2, or subtract 5. We have 2n is equal to negative 5. Dividing now by 2, n is equal to negative 5 over 2. So now we'll see how to solve quadratic equations by factoring. So basically I want to get it to where it looks like this, like n plus something 4 times n minus 3 is equal to 0. So I can solve for my variable. That's just an example, but I want to get it to be a product of two binomials. First thing we need to do is put the equation in general form. General form is when we have it where it's ax squared plus bx plus c is equal to 0, basically all on one side, wherever x squared is positive, and we want to make sure that it's in order from x squared, x, and then the number. So we have n squared plus 8n equals negative 15. N squared is positive there on the left side, so I want to move everything to the left side. So I only need to move that 15. So moving that to the other side, we have plus 15. We're going to add 15 over here. N squared plus 8n plus 15 is equal to 0. Now that I have nothing on the right side, this is in standard form. What I'm going to do now is factor this trinomial, and then we'll solve there using the zero product property. So I already know, okay, factors of n squared, we have n and n. Factors of 15, 1, 15, 3, and 5. Obviously, or we want to look for same sign, give me a sum. They're both going to be positive. Well, factors of 15 will give me a sum of 8. We have 3 and 5. This one will use n and n. They're both going to be positive, so I'm going to have n plus 3 times n plus 5 is equal to 0. I'll equate each of these to 0. So this is my third step now. So n plus 3 equals 0, or n plus 5 is equal to 0. From there, minus 3, n equals negative 3, or minus 5, n equals negative 5. Looking now at this example, first step is always to put it in standard form or general form of a quadratic equation. This is already in general form, meaning to say it's in order, ascending or descending order, x squared, x number. It equals to 0, x squared is positive, we're good. So what we want to do now is factor. So I'm going to find my factors, right? So we have x and x, 1 and 3. We're looking for a sum, and we want them both to be positive. So we want factors of 3, give me a sum of 4, 1 and 3, obviously. So we have x plus 1 times x plus 3 is equal to 0. Using the zero product property, at least one of these has to be equal to 0, so I'm going to set both of them to 0. So x is equal to negative 1, or x is equal to negative 3. So you'll notice now that we're at the end of our school year, we're really just applying everything that we've been learning. It all just builds up into what we have now. Okay, so doing something like this, put it in general form first. We'll move that 33 to the other side, 33k. So I want to subtract 33k from both sides. So we have 3k squared minus 33k plus 72 is equal to 0. Okay, so looking at this, 3, 33, and 72. So if I wanted to use, for example, the quadratic formula, a lot of kids like the quadratic formula. You can use quadratic formula for any quadratic equation and it'll work. But if you had something like this, you'll have really large numbers, right? And that'll be really hard actually to use the quadratic formula. It'll take a long time because it's a lot of computation. For example, you'll have to use b squared, right? 33 squared is a big number. So actually, the first thing you should always try is to solve by factoring and only use a quadratic formula when you can't factor it. So looking at this already, I can tell that I can make this a lot simpler for myself. 3 squared, or 3, 33, and 72, they're all divisible by 3. So I'll just factor out 3 first. So since these are all divisible by 3, I'm able to see this. Okay, so we have k squared minus 11k, because 33 divided by 3 is 11. 72 divided by 3 is actually 24. So now I have a trinomial that's way easier to factor. I'm actually just going to get rid of this 3 right now because if 3 times x is equal to 0, then I only care when x is 0, right? Because 3 times something is only going to equal 0 if that thing is 0. So I'm just going to divide out 3 to get rid of it. So we can say, okay, divide by 3, divide by 3. I can do that because it's only 2 terms here. And that's just going to be 0. So we have k squared minus 11k plus 24 is equal to 0. Now I only have my simpler equation. Factoring this, we'll find our factors, k and k. We have 24 and 1, 12 and 2, 6 and 4, and then 8 and 3. We're looking for a sum. They're both going to be negative. So now we're looking at this. Which one of these will give me a sum of 11? 24 and 1, 25, no. 12 and 2 is 14, no. 6 and 4, 10. Close? No. 8 plus 3 is 11. So I'm actually going to use 8 plus 3 and k. So moving over here, you can say that k, both negative, right? Minus 8, k minus 3. So a lot of students tend to, or that I've met before, they tend to just look at this right here and they'll say, okay, my answer is negative 8 and negative 3. This is not true, okay? This is only for your factoring. Know again that you're going to be changing the sign again once you're solving. So make sure you put it into this factored form first, okay? This is very important, and then solve from there. Then I can say, okay, either k minus 8 is equal to 0, or k minus 3 is equal to 0. From there, plus 8, k is equal to 8, or k is equal to positive 3. So please don't try and skip steps. You want to go from here to your factored form to your solutions. Okay, so now we have something like this. I move everything to one side again. My b squared is positive on the left side, so I need to move this 3 over. I'm going to add 3 to both sides. So 3 plus 3 is going to be 6. We have 6b squared minus 13b plus 6 is equal to 0. We're going to solve, or factor, then solve. Okay, so factors of 6b squared, we have 6b, and b, we have 2b and 3b. 6, we have 1, 6, and 2 and 3. A lot of times we said we want to start with our medium numbers, so let's try using 2, 3, and 2 and 3. Working here on the side, okay, I say 2b, 3b, and then let's just try, okay, they're both going to, looking for a sum, right? They're both going to be negative, so I'm going to make them both negative. Minus, let's just try 3 and 2. Cross multiplying, 2b times negative 2 is going to be negative 4b 3 times negative 3 becomes negative 9b. Adding them, I have negative 13b. Since this is the same as my middle term, this is my correct factorization. So I'm going to say okay. Going back to green. So I'm ending up with 2b minus 3 times 3b minus 2 is equal to 0. Equating each of these to 0, we have 2b minus 3 is equal to 0, or 3b minus 2 is equal to 0. Adding 3 to both sides, 2b is equal to 3. Dividing by 2, we have b is equal to 3 over 2, or plus 2 plus 2. 3b is equal to 2. b is equal to 2 over 3. And now we see these two, x squared minus 9, or this one, x squared minus 9. X squared is a perfect square, 9 is a perfect square. I'm going to use my difference of squares. Again, if I have a squared minus b squared, this is equal to a plus b times a minus b. So this I'll rewrite as a difference of squares. We say it's going to be x squared minus 3 squared is equal to 0. So my a is x, my b is 3. So we have x plus 3 times x minus 3 is equal to 0. Now we'll do, okay, so x is equal to negative 3 and 3 because x plus 3 is equal to 0, or x minus 3 is equal to 0. X is equal to negative 3 or positive 3. You'll notice that you really just change the signs of the one that's with the x, right? If you have a number in front of the x, you'll just change the sign to this one on the right and then divide it by that number. Looking at my last problem here, 4 and 25 again are perfect squares, so I'm going to use my difference of squares formula again. I'll rewrite this. This is going to just be 2x squared minus 5 squared is equal to 0. This will become 2x plus 5 times 2x minus 5. Why do I write my 2 different ways? I don't know. Okay, so from here we have 2x equals, plus 5 is equal to 0, or 2x minus 5 is equal to 0. Solving for x on each side, 2x equals negative 5. Divide by 2, x is equal to negative 5 over 2. We'll try the fast way for this one. I can just change the sign of this one, so it's going to become positive 5 and divide by the number in front of x. Okay, so that's it for this lesson. This is solving equations by factoring, quadratic equations by factoring is the best way or the easiest way to solve a quadratic equation. It only works for trinomials that are factorable. So if it's something that cannot be factored, then you'll have to use the quadratic formula. For all the questions in your assignment today, they're going to be able to be solved by factoring. But in the future, when you're given a choice, you should always, to save time and to save yourself from making little mistakes, solve it by factoring. Try to solve by factoring first, and then if that doesn't work, you can solve using the quadratic formula. There's another way called completing the square, but I don't like that one. A lot of people don't like completing the square. It's like not that great. But these ones are really good, and I hope that you're able to understand this, and I'll be giving you some assignments for this.